So we're going to move on to example 2 of solving simultaneous equations where one is linear and one is quadratic, this higher level simultaneous equations. So you should now have this example, this first example, x squared plus y squared equals 20, x plus y equals 6 in your notes. So we went through that last time in the last example, rearranged the simpler equation, the linear equation, to get one letter as the subject, substituted in, did quite a lot of algebra then to end up with a quadratic that we solved to find the values of one of the letters, and then substituted into the first equation to find our complete pair of solutions. So we're going to go through that process again. We're going to do example 2, and in this example it's exactly the same sort of question, but the equations are just slightly more difficult, a little bit more rearranging to do in the second equation and a bit more sort of multiplying out here, expanding brackets in the first. Okay, so let's have a look at example 2. So again, this is likely to be worth 5 or 6 marks. It'll come at the end of the paper. And here's our simultaneous equations. Solve the equations. 2y equals 3 minus x and x squared plus 3xy equals 10. So just as in the last example, our first thing to do is to make one of the letters the subject of the simpler equation, the linear equation. So in this case, the first equation is linear, and I want to make one of the letters the subject of this. Now I could divide by 2 here and end up with y equals 3 minus x all over 2. But the issue I've got with that then is that I've introduced in a fraction, and sometimes you might have to do that, but if I don't have to do that, I'm going to avoid that. So I could do that, y equals 3x over 2, and then substitute in here, but then I'm going to be multiplying by something with a denominator in, and I think it's going to get a little bit messy. So if I can avoid that, I'm going to. So instead of that, what I'm going to do is to get x as the subject here. Okay, so let's have a look at this. 2y equals 3 minus x. I want to get x on its own. Because it's negative here, I'm going to add x here. I'm going to take x over to this other side just to get it to be positive on this other side. So I'm going to just rearrange that by adding x to both sides. And then I'm going to have my 2y plus x is equal to 3. And now I can get x on its own by subtracting that 2y from both sides. So x is equal to 3 minus 2y. And I'm going to call that equation 1. So now what I'm going to do, I'm going to substitute this into my more difficult equation. So I'm going to call that equation 2. So let's do that. Then let's now substitute for x in equation 2. So everywhere there's an x in equation 2 now. So here and also here, I'm going to substitute in this expression because x is now equal to this in terms of y. So I'm going to substitute that in here. And already you can see that it's a bit more difficult because there's 2 places to do it, but at least I'm not introducing a fraction. Let's have a look. So x squared, so that means, sorry, let me just write that out. So I'm going to write that equation out, I think, actually down here. X squared plus 3xy equals 10. So everywhere there's an x, I'm putting this expression in. So the whole thing squared, so the whole of this thing squared, plus 3 times x, I'm going to put it in brackets to make sure I do the multiplication right, times another y at the end, and that is equal to 10. So what have I done? Everywhere there was an x in my equation 2, I've substituted in this expression where x is equal to 3 minus 2y. So 3 minus 2y squared plus 3 times 3 minus 2y times y equals 10. So we've got a bit of algebra here to do, a little bit of sorting out here, a bit of expanding of brackets. So let's keep going with this. FOIL rule here, because it's going to be 3 minus 2y all squared. So 3 minus 2y times 3 minus 2y. Here I've got a little bit of multiplying out to do. So this bracket, 3 minus 2y, needs to be multiplied by 3 and by y. I can do that all at once, or I'm just going to do it step by step here just so you can see what's happening. So I'm going to multiply in by the 3 and leave the y there to sort out on my next line. 3 times 3 is 9. 3 times minus 2y is minus 6y. I've got to remember to multiply that by that y on my next line. So FOIL rule, 9 minus 6y minus 6y, minus times a minus is a plus 4y squared. And then here I've got to multiply this expression by y, so plus 9y minus 6y squared, and that's equal to 10. So let's collect my like terms here now. And you can see, hopefully, we've now got a quadratic in y. We're going to end up with a quadratic equation equals 0, where we've got so many y squared, so many y's, and a number equals 0, and then we're going to look to solve that. So let's collect like terms here. So we've got 9 minus 6y minus another 6y is minus 12y, plus 9y, that's going to give me minus 3y altogether. So minus 12 plus 9 is minus 3. Plus 4y squared minus 6y squared, so that's going to give me minus 2y squared altogether, and that's equal to 10. Okay, now I've definitely got a quadratic here with y squared in it. I want to end up with an equal 0 here. So when you're solving a quadratic, we always want it to be equal to 0. And what I'm going to do, it would be quite easy, wouldn't it, just to bring this 10 over here. But then I've got negative y squared term. So instead of doing that, I'm going to take all of this and add it over to this side. So I'm going to get 0 equals and then sort that all out on this side. You could do it on this side and then sort the negative out later. But I'm just going to take all of this over here, rearrange it to make 0 equal, and then all of this stuff goes over to the other side. And the reason for doing that is to try and get this y squared term to be positive. And if it was already positive, then I'd leave it where it was. So in our last example, the squared term, the variable squared, in this case x squared, was already positive, so I left it on this side. Here, I'm going to rearrange and take everything over to the other. So minus 9 plus 3y to get rid of that, plus 2y squared. So I'm going to do the same on this side. And that's going to give me the quadratic. Here, everything's gone to 0. 10 minus 9 is 1, plus 3y plus 2y squared. And all I'm going to do here is just change the order of this, so I've got my squared expression first. So 0 equals 2y squared plus 3y plus 1. Okay, we're going to get another sheet of paper now, and we're going to solve this quadratic. So what did I end up with here? 2y squared plus 3y plus 1 equals 0. So let's do that. Sorry. So what was it? It was 2y squared plus 3y plus 1 equals 0. So we've got our quadratic. Let's have a look at our product. So our product here, let me just see, 2 times 1, positive 2. So our product, where I'm multiplying, is going to be positive 2. Our sum, where I'm adding, is going to be this coefficient, positive 3. And this time, there's not much choices. For 2, you've got a 1 and a 2, but that's okay, because positive 1 and positive 2 is going to give me, multiply to give me positive 2, add to give me 3. So this is definitely my combination when I'm going to split this up. So next line in my quadratic, 2y squared plus 2y plus 1y, or you could write that round the other way, it doesn't matter, plus 1 equals 0. Let's look at factorising using our pairs here. So common factor here, 2 and y, so 2y leaves me with y plus 1. So I know that this bracket's got to be y plus 1. I need a plus in the middle, and all I'm doing here, I just need plus 1. So let's just check that. 2y squared plus 2y plus 1y plus 1. So that's definitely right. So finishing my factorisation. And now I've got to solve this to find my y values. So y plus 1 is equal to 0. Take 1 away. Y is equal to minus 1. Or from this bracket, 2y plus 1 equals 0. Take 1 away. 2y equals minus 1. Divide by 2. So y is minus a half. So there's my 2 y values. Again, we mustn't stop there. I'm almost there, but I'm not quite finished. If you remember from our equation, or example 1, once we found the x values in that case, we then found the corresponding values of the other letter by substituting into the easier equation. So let's do that here. So now what am I going to do? I'm going to substitute into equation 1. And if we just look back at our last page, equation 1 was here, x equals, from this linear one, x equals 3 minus 2y. So x equals 3 minus 2y. So let's sort this out. When y is minus 1, that's going to give me x equals 3 minus 2 times minus 1. So 3 plus 2, which is going to be 5. And then if y is minus a half there for my other value of y, x is equal to 3 minus 2, brackets minus a half this time for y. So 3 minus times minus is a plus, 2 times a half is 1, so 3 plus 1 is 4. So my solutions then, let's tell the examiner, my solutions are, where are we? When x is equal to 5, that was when y is equal to minus 1. And our other solutions, when x is 4, that was when y is equal to minus a half. So there's my two solutions to this equation. Okay, so again, they're quite long questions, these, but they are grade 8-9. They do come towards the end of the exam paper, and they are going to be worth a fair few marks. Normally, as I said before, about 5 or 6 marks for these questions. So I'd like you to get both example 1 and this now example 2 in your notes for today. And then in the next couple of lessons, we're going to be doing some practice at this.